Module 5, Chapter 3.1, Complex Numbers. Consider this. If we only had the set of whole numbers 0, 1, 2, 3 to work with, what would the solution be to the equation what minus 5 equals 7? We could solve that and we would get x is 12. But what if we had the equation 2x equals 5? Is there a whole number that we could multiply by 2 to get 5? There's not. So that's why we had to come up with the set of rational numbers so that the solution 5 over 2 or 2.5 would be included. Well, what about the equation x plus 5 equals 2? Well, that one, if you only had the set of whole numbers, anything plus 5 is not going to give us 2. Therefore, we had to introduce the integers to get the negative numbers. So then we could say negative 3 plus 5 is 2. But what about the equation x squared equals 2? Well, there's not an integer or a whole number or a rational number that if we squared we could get 2. Therefore, we had to come up with the set of irrational numbers, meaning x would be the square root of 2. Okay, now this is where this new section comes into play. What about the equation x squared equals negative 1? Remember, we said you cannot square a number and get a negative 1. Remember, any number squared cannot be a negative. So for us, up until this point, there would not be a solution. Therefore, we had to introduce the set of complex numbers. Okay, now the complex number system is an extended number system that includes the real number system as a subset. I don't know if you remember way back when we started, we talked about the reals as either being rational or real or irrational. And then we talked about the rationals being integers and whole numbers and all that. Well, what we've got is, this is a whole set of numbers. But out here, we've got the set of complex numbers, which includes the reals, but it also includes the imaginaries. Okay, so we just extended them so that now we're talking real numbers and imaginary. Now, we defined I to be the square root of negative 1, such that I squared will give us negative 1. Now notice I'm not saying I is negative 1. I is the square root of negative 1, and I squared is negative 1. Now numbers of the form a plus bi, where a and b are real numbers, are called complex numbers in standard form. The a is called the real part. The b, or the number in front of the I, is called the imaginary part. So if we had a number negative 8, that is just a real, or it's a real number. And in standard form, in complex number form, it'd be negative 8 plus 0i. Same as 0. 0 is a real number, but we could write it as a complex number, 0 plus 0i. 3i is a complex number. There's no real part, so we say that is just imaginary. Now, negative I plus 2 is an imaginary number. It's a complex number. It's considered an imaginary number, and in standard form, we do the real number first with the imaginary second, so it would be 2 minus I. 8 plus I squared is 3. That is a complex number. It's imaginary because there is an I part. The real part is 8. The imaginary part is square root of 3. But in standard form, we would just write it as 8 plus I square root of 3. So, if a is greater than 0, then the square root of negative a is going to be simplified as I times the square root of a. For example, the square root of negative 9 means I times the square root of 9, which is I times 3, or 3i. Okay, the square root of negative 5. The square root, and if you want to think of it like this, that would be like the square root of negative 1 times 5. Well, that would simplify to the square root of negative 1 times the square root of 5. Well, the square root of negative 1 is I times the square root of 5. We can't simplify square root of 5, so it just stays there. Okay, let's do a couple more. The square root of negative 36. Well, 36 is a perfect square, so that one would just be 6i. Now, what about square root of negative 50? The square root comes out as an I, and then we've got square root of 50. Don't know if you remember how to simplify these, but you find a perfect square that goes into 50, which would be 25 times 2. The square root of 25 comes out front as an it's a 5, so we get 5i times the square root of 2. Okay, now, what about these? These are the same thing. They say simplify. Now, if it said evaluate, then we would just punch it in our calculator. But because it says simplify, let's use our rules. Well, we know the square root of a negative. We're going to call that negative 1. 80 can be written as 16 times 5. So if we break this apart, the square root of a negative 1 comes out as an I. The square root of a 16 comes out as a 4. Then the 5 stays in, so we get 4i times the square root of 5. Okay, now what if there's a negative out front? Well, that just means our answer is going to be negative. What if there's a square root in the middle under the square root sign? That means it's going to be imaginary, so we can rewrite that as negative 1 times 4 times 2. Square root of negative 1 comes out as an I. Square root of 4 comes out as a 2, and the other 2 stays in, so we get negative 2i times the square root of 2. Now, be careful. When you are doing product rules and quotient rules, you need to rewrite negative a, the square root of negative a, as I square root of a before using any other rules. I'll show you why, because if you think the square root of negative 6 times the square root of negative 10, well, that would be the square root of 60 because a negative times a negative is positive, which would simplify as 4 times 15, so that would simplify as 2 times the square root of 15. That's what people like to think. I'm going to stick a little no up here. Don't do this. What we're going to do is rewrite this as I square root of 6. We're going to simplify the square root of negative 10 as I square root of 10. So what we get is I times I, which is I squared. 6 times 10 is 60. What is this I squared? Well, remember we said I squared is the square root of negative 1. So now the negatives on the outside, now we can simplify 4 times 15. So we get negative 2 times the square root of 15. This is our correct answer. So be careful. Anytime you're doing product rules or quotient rules, you need to simplify your i's before applying any rules. Quotient this time. The square root of negative 48, the negative comes out as an I times the square root of 48. The square root of 24. Now, if you remember your quotient rule, it says you can combine them, so that would be 48 over 24, both under the radical. Well, 48 divided by 24 is just 2, so we end up with I times the square root of 2. Now, on your graphing calculators, the TI-83s, 84s are capable of doing complex number operations. And we wanted to do numbers like the square root of negative 4. Okay, this will give us not a real answer. So what we want to do, anytime we know we're going to be working with imaginary or complex numbers, if you will go to Mode and go down on the bottom, instead of doing real numbers, slide it over to do A plus BI numbers. This means you want your answer in complex mode. Now, if you put it in complex mode, everything you do regarding real numbers will be exactly the same. So now if we go through and do the square root of -4, then we're going to get 2i, so now we're good. So if we were doing something on our calculator, the second square root of -6 times the second square root of -10, that would give us -7.745 and so forth, which is, there's no I, like we said earlier. Okay? Now, all properties of real numbers are extended to complex numbers. That is, we can add, subtract, multiply, and divide complex numbers. Now, to add and subtract complex numbers is just like adding and subtracting like terms. Like terms, letter terms, 3 plus -2 is 1. Letter terms, -4 plus 6i would be plus 2i. To subtract is like subtracting binomials. We're going to distribute the minus to everything inside the parentheses. So we've got a -4 minus 6, which is -10. We've got a positive 3i and a positive 7i, which would give us a positive 10i. Now, your calculator will also do complex numbers, and if you'll notice, there's an I right down here above the decimal point. And what you can do is go through and do 3 minus 4 second I plus -2 plus 6i, which would give us 1 plus 2i, but I still feel like for these type of problems, you're probably better off to just doing pencil paper. Okay, multiplying complex numbers is just like multiplying binomials. Okay, FOIL it out. First 2 times 3 is 6. Outer 2 times 4i would be a positive 8i. Inner 2, -3 times 3i would be -9i. And then the last two, -3i times 4i would be -12i squared. Now, combining like terms would give us positive 8i minus 9i would be -1i minus 12i squared. Now, here's the catch. But, remember, we said I squared is -1. So that becomes 6 minus I minus 12 times -1, or 6 minus I plus 12, which would give us 18 minus I. So that's the only difference in terms of binomial multiplication. Anytime you come up with an I squared, you need to change it over to -1. Let's do another one. First 2, 4 times 5 is 20. Last outer 2, 4 times 2i is 8i. Inner 2, 3i times 5 would be 15i. And last 2 would be 6i squared. Combine like terms, 20 plus 23i. We know I squared is -1, so that's going to become 6 times -1, which would be a -6. So we would get 14 plus 23i. Okay, binomial squared. Remember, this is where you do your binomial times itself, or remember the shortcut. The shortcut says square the first 2, which would be 4, multiply those. 2 times 5i would be 10i, doubled would be 20i, and last 2 would be 5i times 5i, which is 25i squared. But remember, I squared is -1, so that's going to make that a -25. So 4 minus 25 would be -21 plus 20i. Now, if you would rather go through all the steps, 2 plus 5i times itself, FOIL it out, you're going to get exactly the same thing. Okay, 3 minus 4i squared. the little shortcut. I don't know if you remember this. A plus B squared is A squared plus 2AB plus B squared. Or A minus B squared is A squared minus 2AB plus B squared, which says you square the first part, which is 9. You multiply those two, which would give us negative 12I. Doubled would be negative 24I. And then you square the last term, which would be 16I squared. But I squared is negative 1, so that's going to make that a 16 times negative 1, or negative 16. 9 minus 16 is negative 7, minus 24I. Okay, so if you wanted to try that on your calculator, you would just plug in 3 minus 4 second I to the second power, and we get negative 7 minus 24I. Now, let's talk about different powers of I. I to the first is just I. We said I squared was negative 1. How would we simplify I to the third? Well, if you'll remember, that's I squared times I. I squared is negative 1, so that would give us negative I. Same thing on I to the fourth. Actually, I to the fourth, we would call that I to the third times I. Well, I to the third is negative I times I, which would give us negative I squared, or negative of negative 1, which is 1. Now, another way would be to say, well, I to the fourth is I squared squared, which is negative 1 squared, which is 1. I to the fifth is I to the fourth times I, which is just I. Okay, so if we had big numbers, you see the pattern? I, negative 1, negative I, 1. I, and then it just repeats. I, negative 1, negative I, 1. Well, if we're going to simplify larger powers of I, what we can do is just go back and remember I squared is negative 1. So we're going to try and write everything in terms of I squared. Well, I to the 15th is I squared to the 7th. Because remember the power rule says if you're raising a power to a power, you multiply the powers. That gives us I to the 14th. We need another one. So we're going to do I. Well, I squared is negative 1. Well, negative 1 to an odd power would be a negative times the I. So I to the 15th is going to be negative I. What about I to the 42? Well, that's I squared to the 21, because 2 times 21 is 42. Well, I squared is negative 1 to an odd power would give us negative 1. Going to try a couple more. I to the negative 5th. Well, that's I squared to the negative 3rd. That would give us negative 6. Plus one more would be I to the negative 5th. Okay? So that would give us negative 1 to the negative 3rd times I. Well, negative 1 to the negative 3rd is still just negative 1 times I, which is negative I. What about I to the 12th? Well, if we want to write that as a power of I, that would be I to the 6th, or I squared to the 6th, which would be negative 1 to the 6th, which is a positive 1. So, let's go to something different. Complex conjugates. A conjugate of a complex number is a binomial that is exactly the same except the middle sign is different. The conjugate of a plus bi is a minus bi. The conjugate of 3 minus I is 3 plus I. The conjugate of 2 plus 7i is 2 minus 7i. The conjugate of negative 6i, well, if you'll think about it as that as being 0 minus 6i, then the conjugate would be 0 plus 6i. Now, the neat thing about conjugates is when you multiply a number by its conjugate, you're always going to get a real number. not an imaginary number. You notice 3 minus I, 3 plus I would give us 10. 2 plus 7I, 2 minus 7I gives us 53. And when we start simplifying radicals, you need real numbers. Therefore, we're going to use conjugates to get those real numbers. So, if we are dividing complex numbers, we're going to multiply the numerator and the denominator by the complex conjugate of the denominator. Okay? And it says, remember, the product of two conjugates is always a real number. That's important to know. Why is that important? Because later on, when we're reducing radicals, we've got to multiply by something that gives us a real number in the denominator. So, if we wanted to find the quotient 3 plus 2I over 5 minus I, 3 plus 2I over 5 minus I. Now, what's the conjugate of the denominator? If it's 5 minus I, then the conjugate would be 5 plus I. Well, if you do the bottom by 5 plus I, you have to do the top by 5 plus I. So, we're going to FOIL out the top. First two would give us 15, outer two gives us 3I, inner two gives us 10I, and last two gives us 2I squared, which would simplify to give us 15 plus 13I plus 2I squared becomes minus 2, which would simplify to give us 13 plus 13I. Now down in the bottom, 5 minus I times 5 plus I, first two is 25, outer two is plus 5I, inner two is minus 5I, last two is minus I squared. Now, will that always work that the outers and inners will cancel? If you pick the correct conjugate, it will. Well, negative I squared becomes a negative times a minus 1, which would give us 26. So now the question becomes, will it reduce? Well, we could factor a 13 out of everything, so 13 goes into 13(1), 13 goes into 13I, 1I, and 13 goes into 26 2 times. If you need to see those steps, that's 1 plus I over 26, and then we cancel, and we get 1 plus I over 2. Okay, let's do another one. 1 minus 3I over 1 plus I. Conjugate of the denominator would be 1 minus I. Up in the numerator, FOIL it out. First two, 1, outer two minus I, inner two minus 3I, and last two would be plus 3I squared, which would be 1 minus 4I. If I squared is negative 1, that's going to make that a negative 3. So we get negative 2 minus 4I in the numerator. Down in the denominator, FOIL it out. First two, 1, outer two, inner two are going to cancel. Last two is minus I squared. But minus I squared is going to become a positive 1, so our denominator is 2. Cancel, 2 goes into 2 once, 2 goes into 4 twice, 2 goes into 2 once, so we get negative 1 minus 2I, which we could do these on our calculator. Now remember we said, what's the conjugate of 5I? Well, if you'll think about that as being 0 plus 5I, then the conjugate would be 0 minus 5I. So in this case, we're going to multiply top and bottom by negative 5I, which would give us positive 35I over negative 25I squared, which would be 35I on the top. I squared is negative 1, which would give us negative 25 times negative 1, which would give us a positive 25. Then we could cancel. 5 goes into 25 5 times, 5 goes into 35 7 times, so we get 7I over 5. Now, that's the end of Chapter 3.1. So now you're ready to do my Math Lab homework. Good luck.